Now that we know how to get the n roots of a complex number, we are going to apply that to the following example. Find the two complex roots of z equals minus the square root of 3 minus I and plot them in the Argand diagram. When you are asked to find the two complex roots of a complex number, that is equivalent to solving the following equation. W squared is equal to minus the square root of 3 minus I. That is finding the two complex roots. Since this is a quadratic equation, because of the 2, the first thing that we saw in our previous video is that we need the number in the right hand side to be expressed in polar or exponential form, because it makes calculations easier. So in order to get the polar or exponential form, we need to find the modulus and the angle. In this case, just note that x, the real part, is square root of 3, and then that y, the imaginary part, is minus 1. We have seen before that in order to get the right angle of your complex number, it helps if you plot your complex number first in order to know in which quadrant it's placed. Therefore, in this case, we are going to place the number that has x equal to minus the square root of 3 and y equal to minus 1, which gives you the following graph. Therefore, you know that your number is placed on the third quadrant, and you know that angles in the third quadrant are between pi and 3 pi over 2. Right, the first thing is going to be finding the modulus. And remember, to find the modulus, we just do the square root of x squared plus y squared. So x is minus the square root of 3, y is minus 1. If we square this, we get 3, and if we square minus 1, we get 1. Therefore, that gives us the square root of 4, which is 2. I have used this notation here, which is equivalent to using r. Now, in order to get the angle, remember that to get the angle, we do tan of theta is equal to y over x, which gives us 1 over the square root of 3. In order to find theta, we can use, if it's a known trigonometric ratio, we can use the calculator or we can use the log tables. In this case, if you use any of them, you will come up with an angle of pi over 6. But if you realize your number is placed in the third quadrant, therefore pi over 6 is not the right answer. Pi over 6 is what we call our reference angle. Since we are looking for an angle in the third quadrant and we know an angle in the first quadrant, which is pi over 6, we can get the angle we are looking for by simply adding pi. So our theta would be pi plus pi over 6, which is 7 pi over 6 radians. Now that we know theta and we know the modulus, we can get the solutions we are looking for by applying the formula that used before. Remember, WK, where K indicates the root you're looking for, and it varies from 0 to n minus 1, is equal to R, which is the modulus, to the power of 1 over n, where n is the number of roots, by e to the power of theta, which is the angle, plus 2 pi k, and k goes from 0 to n minus 1 over n, which is the number of roots, by I. So this question now then is only a matter of identifying r, n, k, and theta. In our case, we know that r is equal to 2. We know theta was equal to 7 pi over 6. Now n is the total number of roots you're looking for, and the question said find the two complex roots, so n is 2. And since you're looking for 2 roots, your k will go from 0 to 1. So then we are going to have W0 and W1. W0 is going to be R, which is 2, to the power of 1 over n, which is 1 over 2, by e to the power of theta, which is 7 pi over 6, plus 2 pi k, k is 0, everything over 2 by I. So we have 2 to the power of a half, which is the same as the square root of 2. Then we have e to the power of, realize that 2 by pi by 0 is just 0, so we have 7 pi over 6 all over 2, I. So we have the square root of 2 by e to the power of 7 pi over 12i. That is your first answer, which has modulus equal to the square root of 2 and angle equal to 7 pi over 12. Now we go for the second rule. We have r to the power of 1 over n, which is the same as before, 2 to the power of a half by e to the power of 7 pi over 6 plus 2 by pi by k, and k is 1 this time, so we have 2 pi over 2i. So we have the square root of 2 by e to the power of, and now if we add these two numbers here, we get that that is the same as 19 pi over 6, everything all over 2, which gives the square root of 2 by e to the power of 19 pi over 12i, which is a complex number with modulus equal to the square root of 2 and angle equal to 19 pi over 12. Now that we have the roots, we're going to plot them in the Argand diagram. So for that, remember, we need to draw a circle of radius square root of 2, which is the modulus, and then we need to find where the two angles are placed, and we need to place two different angles, and we have two angles. Theta 0, which is 7 pi over 12, and then theta 1, which is 19 pi over 12. Place the angles. It will help if you think about half of the circle as pi and you divide that into 12 sections. You can also think about a quadrant divided into 6 equal pieces. If you do so, you will obtain the following diagram.